REDCap has a powerful randomization module that should be used for investigators performing randomized clinical trials. The goal of today's presentation is to show you how to randomize patients into a randomized trial from any computer with internet access. And the hope is that this would completely replace the expensive randomization services that are offered by third-party services. And the question is, why would anyone want to use central randomization? Well, in contrast to sequential sealed envelopes, using central randomization is convenient because you do not have to create a series of envelopes that is stored in a particular location. In addition, this will work from any computer that has internet access. And because nobody knows what the next allocation will be, and no one can check the next envelope holding it up to light or by opening it and then resealing it to see what the next allocation is, you can be assured that allocation concealment is going to be enforced. Finally, once the randomization is performed within REDCap, this cannot be changed, and all of these measures can reduce bias in clinical trials. There are several important factors. We need to ensure before randomization that all the patients about to be randomized satisfy all of the inclusion criteria and none of the exclusion criteria. If we randomize subjects and then check their inclusion and exclusion criteria, this will result in several people being eliminated from data analysis, and this is not desirable. We may also want to stratify randomization by the enrollment site to ensure that we have equal numbers of intervention and placebo patients at each site. And we ideally would like a permanent, unchangeable record in REDCap of the group allocation. So this presentation will demonstrate how to create basic data collection instruments in REDCap. It'll show an example of a calculated field. It will show you how to create randomization lists in Stata for simple blocked randomization as well as stratified randomization. It will show you how to import these randomization lists that you have generated into REDCap, and finally how to perform the randomization within REDCap. And we're going to frame this discussion around a fictitious randomized clinical trial. The intervention in this fictitious trial will be a drug called levosimendan, and we're going to be comparing this drug to placebo for patients who have impaired heart function with the left ventricular ejection fraction less than 30%, undergoing CABG or coronary artery bypass grafting. The intervention will be an intravenous infusion of levosimendan intraoperatively and then postoperatively for a total duration of 24 hours. The sample size will be 100 patients in each arm, and the primary outcome will be death at 30 days postoperatively. And of course, for the purposes of this presentation, we're going to be stopping at this one outcome, and in your clinical trial, you will change the outcomes and the intervention as required. This is just as an example. Now, it's important that we define our inclusion and exclusion criteria because we will be using these fields within REDCap to ensure that only patients who are allowed into the trial are ultimately randomized. Our inclusion criteria here include an age over 65, having isolated coronary bypass grafting. In other words, we will not enroll patients who are having planned valvular surgery. Of course, the patients need to have informed consent. And we don't want people who are coming for a redo heart surgery. In other words, they've had a previous heart surgery. And we certainly don't want patients who are allergic to the intervention. So patients with an allergy to levosimendan will be excluded. Now, we're going to be rolling in patients during this clinical trial at two hospitals, Hospital A on the top and Hospital B on the bottom. And in the first example, I'm going to show you how we perform simple blocked randomization and some of the problems associated with this. Now, specifically, this method does not guarantee that the proportion of patients receiving levosimendan at each hospital is the same, and this can be a problem. In fact, it's possible that just by chance alone, if we only draw up one randomization list, Hospital B may have more patients receiving the intervention, levosimendan, and Hospital A may have more patients receiving placebo. Now, if the hospitals performed exactly the same, this would not be a problem. However, if Hospital B has better doctors and nurses, and is associated with a better prognosis than hospital A that's independent of any studied drug effect, then this will confound our results and it will actually make levosimendan look better than it really is. So because the site of the intervention may be associated as a prognostic factor for the outcome of interest, we need to ensure that equal proportions of patients at each site receive both intervention and placebo. And I'll note that this is only an issue within small randomized trials. However, small randomized trials represent the preponderance of evidence in some specialties, including most perioperative medicine trials. Now let me show you what I mean. Let's say instead of 200 patients, that we'll instead be looking at 20 patients. And so you can see I have 10 patients in each arm, 10 placebo and 10 active intervention, and in this case that would be the levosimendan drug. If we form a simple randomization with one randomization list, we will end up potentially with an imbalance of patients receiving the intervention and placebo at each of the sites. The first randomization occurs at hospital A, and this person is assigned to the placebo arm. The next randomization occurs at hospital B, and this patient receives the active intervention arm. The third randomization occurs at hospital A, and this patient receives the active intervention. The fourth randomization occurs at hospital B, which receives placebo. So far, so good. We have an equal proportion of placebo and active intervention at each site. However, due to chance alone, this may not occur. In fact, it's quite common to generate runs of placebo or active intervention in a randomization list. So if this occurs, we may see that the next 3 patients, all of whom are enrolled at hospital A, are receiving placebo. And just by chance alone, the next 3 patients who are enrolled at hospital B are all receiving active therapy. We then continue this process until we have randomized everybody. But what you'll see here is that by using simple randomization, we have an imbalance of the proportion of patients receiving active therapy at hospital A, in which case only 3 out of the 10 of the patients at this hospital are receiving active intervention, whereas at hospital B, 7 of the patients there have received active intervention. As I mentioned before, this is a problem because we know that hospital B is independently associated with better outcomes because their quality of care is higher. So when we're analyzing this study, we won't be able to tease out the effect of the hospital itself from the additional effect of the intervention. So what can we do to address this? Well, in the second example that I'll show you today, we will randomize patients stratified by site to ensure that equal numbers of patients are receiving active drug and placebo at each site. Within each site, we will still use randomization blocks to ensure that at any time during the study, there are roughly equal numbers of patients assigned to each group so that we don't have an imbalance at any given moment in time. So how does this look? Well, recall that we're randomizing 20 patients in total. And for simplicity, let's say that 10 are going to be randomized at each hospital. So in contrast to the previous example of simple blocked randomization, stratified randomization will generate 2 randomization lists, one for each stratum. And the stratum in this case is simply the hospital at which the patient is enrolled into the study. So for hospital A, we will generate a randomization list. This will have 10 assignments, 5 of which are placebo and 5 of which are active. And for hospital B, we will do the same thing. And at the end, we will result in 2 randomization lists, each containing 10 allocations, each of which has an equal number of placebo and active arms. On the left, you can see that hospital A's first randomization is to placebo, and hospital B's first randomization is to the active therapy arm. We continue doing the randomization allocation, and because we know within each randomization list we have equal proportions of placebo and active intervention, by the time we're finished the randomization, we are guaranteed to have 5 active intervention in Hospital A and 5 in Hospital B. This has eliminated the chance that we see a difference in treatment effect that is not actually due to the treatment and rather due to a prognostic factor, such as the hospital site, that is predictive of a better outcome. So, part 1, I'm going to show you how to set up the REDCap project to enable the randomization module. Before we can do any randomization, we need to actually set up a project. So I'm going to go to my organization's login screen for REDCap and go ahead and log in. And you'll see that I'm presented with a list of projects which already exist. And for the purposes of this training, I'm going to go right to the top and say create new project. And we're going to call this project levosimendan versus placebo in coronary artery bypass grafting. This is going to be a just for fun project that will be deleted later, and I'm happy to create an empty project with a blank slate. So let's go ahead and create that project. Now, most of this configuration screen does not need to be altered for the purpose of this presentation. However, the one thing that is obviously relevant is the randomization module, so I'm going to enable that. And before we can get going, I need to create a few data instruments, data collection instruments. So I'm going to click on Online Designer, and I'm going to go ahead and create the instruments that I need to create. REDCap will include my first instrument as the default, and I'm going to rename this. And I'm going to rename it as baseline data. So we'll save that. And I'm going to create another instrument, and I'm going to create it below, and this one is going to be called randomization. And then finally, I need an instrument to put my outcomes in, and for the purposes of this presentation, there will only be one outcome. And I'm going to go ahead and create that below randomization, and we'll call this one outcomes. Alright, so now we have the 3 instruments that are relevant to our project, and we're going to drill down into each of them to create the fields that we need. So let's click first on baseline data. Now I would like to have a header that says demographics, but I need to have a field that exists before I can do that. So you'll notice that if I want to create a field below the default field, which is the record ID, and that cannot be deleted, I go ahead and click Add Field. I'll select the type of field as being a new section, and I'll type demographics. However, I'm going to get an error from REDCap that says that section headers can't be the last field on the data entry form because there needs to be something below them. So in fact, we'll create these after we've created a couple of fields. Okay, so we're going to add our first field, and we're interested in adding the sex of the patient, which will be a mutually exclusive choice between male and female. So we're going to click on radio buttons here. We're going to call the field label sex, and we're going to add 0 for male, which will be encoded as 0 in REDCap, and we're going to put 1 for female. And then the variable name, which is the critically important part for statistical analysis, we will call female. And you can see that when the choice is going to be 1, this will be female, and so when you're doing your statistical coding, it will make it natural to say if female is true, then you know the sex of the patient. We're going to say this is a required field, and it is not a personal identifier. So we'll go ahead and save that field. Okay, the next field we're going to add is going to be for the patient's date of birth. So we are going to select a text box that includes date and time. You can see right there. So we'll click on that. We will label the field date of birth, and we will assign the variable name of DOB. We do need to validate this. We want to force the user to enter as the month, day, and year, so I will click on that. and we are going to require the user to enter this information. In addition, date of birth is at least a partial identifier for the patient, and so we will click that this is an identifier field. And the benefit of indicating that this is an identifiable field is that when we export the data, we will have the option of excluding identifiers, and that would exclude the patient's date of birth. So we'll go ahead and click on Save now. And the next field that we need to add is another date, which is the date of surgery. So I have left the field type as text box, and we're going to name this field date of surgery. We will once again use the same validation as month, day, and year, and we will require the user to enter this. This, however, is not an identifier, so we will leave that as being no. So let's go ahead and save that field. And given the date of birth and the date of surgery, we can calculate the age of the patient at the time of surgery. So I'm going to click on Add Field. I'm going to go down to Calculated Field and select that as the field type. The field label here will simply be age. And the calculation equation is not really the focus of this presentation, but I will briefly explain the formula. Okay, so I'm going to paste in the formula here, and essentially we're calculating the difference between two dates using the dateDiff function. The two relevant dates are the date of surgery here and the date of birth here. Both of these variables are contained within square parentheses, which indicates that the value of that field will be substituted at the time of calculation. Once we've calculated the date difference, this will give us a number that includes a decimal place. And so the round down function will round down to the nearest integer, and the 0 simply means we don't want any decimal places. Now, the variable name for this variable is going to be simply called age, and it will also be required, but of course if the other two fields that it depends on are already filled out, then this will automatically be filled out. So we'll save that. And finally, we are going to add our headers. So just to show you how that's done, now that I have a field below the record ID, I can click on Add Field below record ID, and I can go to Begin New Section, and I'll type demographics. And you'll see that this now adds a header field, which in long forms can certainly make the form a lot easier to read. Now we need several other variables, and to save time, I'm going to go ahead and add these. So as you can see, I have added 5 more fields. I've added a header that then says other information. I've added the hospital site, which is a radio button that forces you to choose between hospital A and hospital B as the site of surgery, and the name of that variable is simply hospital. I have added a variable called planned surgery, which ensures that the patient will only have the procedure for which patients are included in this trial, which, as you will recall, are CABG only patients. So if the patient is having valve only or a combined procedure, then these patients will be excluded, and I'll show you in a second how we will do that. I have a variable called redo, which shows whether or not this is a redo surgery, and again, this is one of the exclusion criteria. I have a variable called allergy, which indicates if the patient is allergic to levosimendan. And finally, I have a variable called consent, which says, has informed consent been obtained? Now we'll move to the next instrument that we need to fill out. And so we're going to click on Return to List of Instruments, and we will click on Randomization for the randomization instrument. Because this is an extra instrument, you will see that this one starts out blank. It does not have the required field of study ID, as this is only required on the first instrument that you create. Now, technically, the randomization does not need to be on a separate instrument. However, I recommend that you do make it a separate instrument because it allows you to conceal the group allocation for those people that you want or need to remain blinded to the group allocation. For instance, if you have a study coordinator, that person will need to be able to randomize patients, but you may have data entry personnel for whom you do not want them to be able to see the group allocation. In the user rights section of REDCap, you will be able to exclude the data entry personnel from being able to see this instrument, and that will prevent them from seeing this field. Okay, so we want an option to be able to randomize patients, but only after we have determined that the patient is eligible. So first we're going to create a variable to determine that the patient meets all of the inclusion criteria and none of the exclusion criteria. So the first field will be a field that allows the user to confirm everything is okay, and then the second field will be for the actual randomization. So for this first field, we're going to create a variable called confirm, and this is going to be a simple yes/no field. So we will enter the text here. It appears that all inclusion criteria have been met and no exclusion criteria have been met. Confirm that the patient is eligible for the trial and that written informed consent has occurred. We will call this confirm, and we will make this a mandatory field. The next field that we are going to create will be the key field for the whole presentation. This field will contain the group to which the patient has been allocated. So the field type is going to be multiple choice, radio buttons, and we will label this field the group to which the patient has been randomized. And then starting with the numeral 1, we will enter our choices. So numeral 1 will be placebo, and numeral 2 will be the levosimendan. We will call this variable simply treat, and this will be a required field as well. So let's go ahead and create that. Now, I don't want this field to show and give the user the option of randomizing a patient unless we know for sure that the patient is eligible. So we're going to hide this field unless the answer to the field called confirm is yes. If the answer is no, or if this is empty, then this field will not show up and the user will not have the opportunity to randomize a patient. So let's go ahead and create that, and to do that we go under what's called branching logic, which is the green arrows here. So I'm going to click on that, and you will see the Add Edit Branching Logic dialog box show up. There are two ways to create the logic behind whether or not a field shows up. That is using the simple drag and drop logic builder, or the more advanced syntax where you can create your own criteria. And for this, it's very simple, so we will use the drag and drop logic builder. So you can see that we want to show the field only if all of the below are true. Right now this box is empty. And we have choices that we can use on the left. And this first one is very simple. If the field called confirm is assigned to the value yes or 1, then we want to show the field. So I'm going to drag this first line here where it says confirm yes over to the right and then let go of the mouse. You will see that although it's grayed out, you can see the advanced logic above. And this is basically just stating that if the confirm field is equal to 1, then the randomization field will show. And that's exactly the behavior that we want. And so we're done with this dialog box, and we'll just click on Save. Now, for the previous field, where it says that all inclusion criteria have been met and no exclusion criteria have been met, we also need to apply branching logic to this field. However, it will be a little bit more complicated because we need to test multiple criteria. So let's go ahead and click on the branching logic icon, and you will see this familiar dialog box appear. Now, the logic for here is based essentially on fields from the previous instrument, which was the baseline data. So we're going to click on the baseline data instrument to show the fields from that instrument. And let's review again the inclusion and exclusion criteria. The first thing that we need to confirm is that the age is greater than or equal to 65 years. And so I'm going to drag and drop the age field over to the right. I'm going to change the inequality to be greater than or equal and I'll type the number 65. So that's our first criterion. Our next criterion is that the patient is having isolated CABG surgery. Remember, no valve surgery will be acceptable. So if we scroll down, we'll see the 3 values for that field that we previously assigned. And I'm going to take the first one that says CABG only, and I'm going to drag and drop that to the right. So you can see that so far we're going to show the field only if the age is over 65 and the planned surgery is CABG only. And that's the behavior that we would like. We need to also confirm that informed consent has been done, so I will drag this field that says that consent has been done over to the right. And as before, you can see the expression being built above. Now, we also need to make sure that the exclusion criteria are working for this patient. So remember, we don't want to have any patient who's having redo surgery. So I'm going to take the redo is no, which is 0, and I'm going to drag that over here. Now keep in mind, if I drag the redo is yes, that would show the field if that was true, and that's not the behavior that we want. Finally, we are excluding patients who are allergic to levosimendan. And so if they have an allergy, which is yes, we don't want that. We want all the patients who do not have an allergy. So I'm going to drag and drop that field over here. And so if you look at the top, we have defined our logic. The patient must be greater than or equal to 65. The planned surgery has to be equal to 1, which we know if we just scroll up here, we can see the values, which is CABG only. The consent is 1, which means that the consent has been filled out, and it's yes. The redo is 0, which is no, and allergy is 0, which is no. And that's exactly the behavior that we would like. So we're going to go ahead and save that now. And now we're done with the randomization instrument setup. The final instrument that we have is where our outcomes will be stored. So I'm going to click on Return to List of Instruments, and we'll go to Outcomes. This is where we're going to store the one variable, the one outcome that we have for this study, which is 30-day mortality. And so I'll create a field that says yes and no, and I will just type in the text, was the patient alive 30 days after the operation? And we will name this alive _ 30 day. And we'll make this a required field. So we'll go ahead and save that. So now we're finished, and if I return to the list of instruments, we have completed all of our necessary setup. We can now move on to creating the randomization list. So now that we have created our REDCap project, the next step is to create the randomization sequence. For this, you can use any software, including popular spreadsheet programs, but I'm going to demonstrate this using Stata, because it has a particularly good program for generating randomization sequences. If you are using other software, just be sure that you create your treatment and placebo groups using the numerals that I have depicted in this presentation. The first thing that is important to understand is that REDCap uses different randomization lists for testing in the development phase and for actual clinical trial recruitment in the production phase. As you can see from my folder structure, I recommend that you have separate folders for the development and production domains so that you can generate your randomization lists easily for each of them and to keep them segregated. So let's start constructing our randomization sequence. You can see that I've started Stata, and what we're going to do first is ensure that the program that will generate the randomization sequence is installed. To see if the program is installed, type which ralloc, where ralloc is the name of the program, and if the program is installed, you will see output similar to this. If the program is not installed, you will receive an error, at which point you will type ssc install ralloc, and then you'll be able to move forward. The next thing you're going to do is to ensure that you have changed the working directory to the current directory where you want the randomization list to be stored. So click on File, Change Working Directory, and then go to the folder where you want to store the information. I'm going to select development so that it is clear that this is for the development randomization list. Any files that you create will now be stored in this folder. Now we are going to go to the File menu and click on New, Do File. This opens up a text editor where we can paste in the commands that we need to generate our randomization sequence. Anything that you see that is green are simply comments, and they are not executable within the program. You can see that I've issued the command ralloc, and I've issued the three variables block, size, and treat. These will be the variables where the block, the size of the block, and the treatment allocation will be stored. I've set a random number seed, which could be any number, but this ensures that every time you run the program, you will obtain the same results. Critically, the difference between the development and the production phases for randomization lists only involve changing the seed. Now, because we are randomizing 200 patients into this study, and because there may be patients who are mistakenly randomized, we are going to generate more randomizations than we actually need. So I've set the number of subjects at 250. The ratio between placebo and intervention groups is going to be 1. The number of treatments is 2. And I want to set some blocks so that we ensure that at any time during recruitment, we will have approximately equal numbers of patients in both the placebo and intervention arms. And the block size is going to start at 2. The rest of these options are very clearly described in the ralloc help file, which you can obtain by typing help ralloc. This will open up a complete documentation of all of the features and options of the ralloc program, and I encourage you to read this if you are interested. Let's go back to our do file. After we have generated the random allocation sequence, we will add a unique identifier for each study participant. We will save the list, and then we will export it into the file format that is used with REDCap. This is the comma-separated values format, or CSV. You will note that for the simple randomization, we are only exporting the treatment. We don't need any other information. When we click on Do, this will execute the code within Stata, and we can see that the random allocation sequence has been generated. If I type tab treat, this will show me that we have 125 patients assigned to the control arm and 125 patients assigned to the levosimendan arm for a total of 250, and this is exactly what we asked the command to produce. You will now see that you have a randomization list CSV file in your working directory. This is the file that you will import into REDCap to actually perform the randomization. The file itself consists of only one variable called treat and numbers indicating whether the patient is in the placebo 1 or levosimendan 2 groups. We would expect that there's 250 numbers, and indeed that's what we see. Now we will return to REDCap to actually import the randomization sequence into our project. Click on Project Setup. We've already enabled the randomization module, but you can see that the option to set up the randomization module is not yet there. This is just due to the user rights. If you click on User Rights and scroll to the right, you will notice that randomization currently is not allowed within my user privilege set, so we must change that. I'm going to click on my name and select Edit User Privileges, and I'm going to add all 3 randomization privileges to this account. I will then save the changes. Now let's head back to project setup, and you'll see that the option to set up randomization is now enabled. We will click on that, and there will be several questions about the randomization model that we will first have to answer. For simple randomization, we are not going to use stratified randomization, and so all that we need to select is our randomization field. You will recall on our second instrument that we set up a field called treat, and that is where the randomization is going to be set. So I will select treat. Then we just need to click on Save Randomization Model. Importantly, the numbers that we originally assigned in our randomization instrument to the treatment groups, if you recall, it was number 1 for placebo and number 2 for levosimendan. These numbers must match what is in your CSV file. So now we will click on Save Randomization Module. We will then go down to uploading our allocation table. You will see that there are 2 areas to upload tables. The first is for the development phase of your project, and the second is for the production phase. Because we have only generated the randomization sequence for the development phase, I'm going to click on Choose File. I will navigate to the randomization list, and I will click on the CSV file that we generated. I will then choose that file, and then finally click on Upload File. You can see that REDCap has told us that the randomization allocation table was successfully uploaded. Now let's see what this looks like in real life. If we click on Add and Edit Records, we can choose to add a new record. This will be assigned the record ID of 1, and then I will go ahead and enter some data. You will see that with the birth date in 1938 and surgery occurring in 2016, our calculation field has worked correctly and provided us with the age of 78. Let's say that the patient is going to be operated on at Hospital A and for CABG surgery only. It is not a redo surgery, the patient is not allergic to levosimendan, and informed consent has been obtained. So let's save this and go to the randomization form. Now, because the branching logic that I set up earlier has all been met, we do see this field, and it's asking one last time to ensure that all inclusion criteria have been met and none of the exclusion criteria have been met. We will click on Yes, and then we will see the randomization field appear. Again, we set this up using the branching logic, and it is working. I will click Randomize, and just before I commit, the REDCap program will ask me to be sure that I want to randomize this patient. Additionally, when we're in development phase, it will give us a warning not to randomize real subjects at this point. Let's click on Randomize. It tells us that we have successfully randomized study ID number 1 to the value number 1, which is placebo. Remember, this number must match between the value labels that you set in REDCap and the value labels that you generate in the randomization table. You will also notice that the ability to change the allocation has been taken away from you. This is grayed out, and it will say already randomized. Now let's go and see what would happen if our patient that we added did not meet the inclusion and exclusion criteria. So we're now at patient 2. This is a woman who is not that old. She's also having a surgery today at Hospital B. The other inclusion and exclusion criteria are okay. But because she is only 20 years old, when we go to the next form, you will not see the question that asks us to ensure that the informed consent has been done. This protects you from mistakenly randomizing a patient who is not eligible for the trial. Let's go back to baseline data and fix our mistake. Instead of 1996, let's say the patient was born in 1936. The age updates to 80, and if we save and go to the next form, we will now see the field that allows us to open the randomization field. So let's say that all inclusion criteria have been met, and we can randomize this patient as well. This patient has been randomized to the levosimendan group, which is number 2. Now, how does it change when we want to perform stratified randomization as opposed to simple randomization? In the Stata do file, you will notice a couple of small differences. First of all, we have changed the seed number so that it is distinct from the development randomization list. Secondly, because the number of subjects is per stratum, I have changed the number of subjects to 150. Because there are 2 strata, one for Hospital A and one for Hospital B, there will be a total of 300 randomization allocations. You will also notice that we have some stratum labels at the bottom. Finally, you will notice that when we are exporting not only the treatment allocation, but also the hospital stratum. This will allow REDCap to understand which list to be using for which patients. It will match the number that we have assigned for hospital in the random allocation list to the number that we used for hospital in our value labels in REDCap. Again, it is critical that these match. When we run the do file, a new CSV file will be generated. And if I open the CSV file that was generated, you will notice that instead of just the treatment allocation, we now have the treatment allocation labeled 1 for placebo and 2 for levosimendan, as well as the hospital. So these are essentially 2 different lists. Number 1, hospital has its own list, and let me scroll down. After 150 patients, you will see it switches to hospital number 2. These are essentially 2 different randomization lists in one file. Again, we asked to randomize 300 patients, and that's exactly what we received. Now, when we go to the REDCap Project Setup tab, we will once again set up our randomization by clicking Setup Randomization. However, this time, because we have stratified randomization by site, I'm going to click on Randomize by Group/Site. I'm then going to click on Use an Existing Field to designate each group or site. This is asking us essentially which randomization list we want to use, that for Hospital A or Hospital B. And we stored this information in the hospital field, so I will click on that. And then we'll select our randomization field. This is where our treatment allocation will go, and as you will recall, this is the variable treat. We will then save the randomization model. Once again, I will choose the file that I want to upload for the development phase, and this must be done separately for each phase, development and production. This is the CSV file that I want with the 2 variables, and I will choose this and upload it. So now that we have done that, if we add a record, we're starting new. So this is record number 1. I'll just enter some data. Let's say we are randomizing the patient at Hospital A. We will confirm, and now we will randomize. Because we're performing stratified randomization, REDCap wants one final assurance that we are selecting the correct hospital. This will be pre-filled because it was on the demographic variable. But let's say randomize. It will now tell us that the patient has been randomized to the placebo group. Once again, if we add another record, this time for Hospital B, it will allow us to use the other randomization list so that we ensure we have equal proportion of treatment and placebo in each site. When you believe that you've set everything up correctly, it is critical that you test what you've done. The first thing you should do is to ensure that there is a reconciliation between the CSV file that you generated and what is contained in REDCap. So you must serially create new records, randomize them, and ensure that they match what you set up in your CSV file. I would recommend that you do this for 4 to 6 patients per stratum. So you can see here in REDCap the patient was assigned to placebo, and indeed in the CSV file, number 1, placebo, was what was supposed to be assigned. Number 2 was given levosimendan, and indeed that is correct. Patient number 3, also levosimendan, and so on and so forth. Other tests that you need to make sure that you accomplish are that you must ensure that you cannot randomize ineligible patients. In other words, you're testing your branching logic here. You should test all of the combinations of the inclusion and exclusion criteria to ensure that it is set up correctly before you move to the production domain. The last part of this process is simply to switch to production mode. In REDCap, if you want to change to production mode, click on Project Setup, scroll down to the bottom, and click on Move Project to Production. I hope you have found this introduction to the REDCap randomization module useful. If you have any questions, please don't hesitate to contact me by email.